now to our last speaker, who is Laura. Laura is also a chemical engineer, also based in Valencia, with a master's from Cranfield University in the UK. She has a track record working in research and development and also project management at international companies, and she joined AIDIMME in 2017. Since then, she has contributed to many national and international projects, and she has transferred, or she's transferred at the moment, her knowledge and experience to MSc students at the Polytechnic University of Valencia, where she's also undertaking her doctoral studies. I'm sure that you're making a great role model for them, Laura. And as regards to the project LIFE Waste2Coag, she works with AIDIMME in the design, commissioning, and operation of the electrolytic pilot systems. So, without further ado, Laura, the floor is yours.
Can you hear me now?
Yes.
Okay. I will try to share my screen. Please let me know if it's working. Do you see the presentation?
Yes, it's loading now.
Okay, thank you. Thank you, Blanca, for the introduction. In this presentation, we will first review the technical concepts of our project. Then we are going to see the key innovations of our LIFE solution. Then we will explain the metal scrap selection for our system and see some pictures of the coagulants that we have generated in the pilot plant. Okay, as you know, this is a multi-sector approach because all the different streams of the project come or belong to very different industries. As you know, the main objective of the project is to generate high-quality coagulants, which are going to be used in the wastewater treatment plants, both from industrial plants and the wastewater treatment plants. For that, we need to control the key parameters of the electrolytic system, and we have to be very careful with the inputs of this plant. On the one hand, we have the brines, which are the high conductivity liquids that come from desalination plants and from industrial plants. And on the other hand, we have the scrap metals that come from the metal industry. The focus of today's webinar is going to be the selection of these scrap metals, okay? A quick review, the coagulation is a wastewater treatment in which we destabilize the polluting particles from water so they can settle and they can be removed from water. The conventional coagulation does this by means of the addition of reagents like chemicals such as the iron and the aluminum salts. And in the electrocoagulation, we are doing the same, but by the use of the electric current. So we can generate the active species directly, okay, in situ. But what are the main difference of the electrocoagulation and the electrolytic system that we are using in this LIFE plant? In here, we are going to see the comparison of the electrocoagulation and our system, okay? First, the objective of the electrocoagulation is normally the wastewater treatment, while in our case, we want to produce coagulant and valorize the wastes, okay? Both the metal scraps and the brines. As for the electrodes, in the electrocoagulation, normally we use commercial electrodes, while in the electrolytic systems of the LIFE, we are looking to valorize the metal scraps, which normally are cheaper, and it's good for the environment because you are valorizing these wastes. On the other hand, the electrolyte in the electrocoagulation is normally the wastewater that you want to treat. And in our case, we use the brines, which are high conductivity liquids, which means that we use a lower power consumption, and we prevent them from being released to the environment, which is harmful for the ecosystem because of the high salinity of these liquids. Besides, regarding the versatility, the electrocoagulation is normally a standard process, while in the LIFE Waste2Coag, we have to cope with a wide range of qualities, both from the metal scraps and the brines, and also we have to be able to deliver a wider range of qualities of the coagulant, depending on the necessities of the end users. Okay, the input and the final requirements are usually not the same. As the similarities of both processes, we have that they are both easy to operate because they can be controlled by the power source. So with the power source, you can control the reaction and you can generate the amount of coagulants that you want in situ. None of them uses reagents in terms of acids or bases, or the coagulants, of course, which means that we produce less sludge, which is good. Okay. As the main advantages of our process, we have first that we generate commercial coagulants, that they can be commercialized or used in situ in your plant. We are valorizing wastes, the metal scraps and the brines, and we have a low power consumption because of the high conductivity of these brines. As for the scrap metals, we have said that this is obviously not a direct operation. For the metal selection, we had that we will talk about the quality in the next slide. Then about the price, we know that no one can guarantee a stable price nowadays, but at least we are looking for a lower price than the commercial electrodes. Then as for the shape, the scrap market has a wide array of shapes going from profiles, coils, corners. And in our case, we are limited by the reactor configuration because we are using a filter press configuration. And that means that we have to use the flat sheets, as we can see at the bottom right of the slide. Okay, as for the thickness, dimensions, and quantity, these are physical specifications that depend on the quantity of the coagulants produced. As for the thickness, the more weight, the more metal that we can dissolve. So we have to make sure that the thickness is enough to withstand all the project duration for the coagulants that we want to produce. For the dimensions and quantity, they are defined by the current density that we want to apply in our process. So we will have to shape this as well and define this as well. And finally, we had to look for a good availability. Of course, the metals have to be ready for when we wanted to buy them in the process. Last but not least, we had to seek and select the supplier that met all these requirements, which is not easy. Okay. Then the quality requirements, as we have said, not everything is welcome in this plant. We are looking for the highest purity of the metals, or else we can contaminate water, we can inhibit the biological treatment, or obtain a low quality of the coagulants because of the impurities that the metals may contain. Okay, for example, in the case of the ion electrodes, the use of the stainless steel or galvanized steel is directly not allowed because they contain a high amount of chromium or zinc in this case. For the aluminum electrodes, we are looking for the series 1000, 5000, and 6000 because they contain a low amount of the alloying elements, which are, in this case, for example, the manganese, the zinc, and copper. So we are looking for both of them a high purity. In the project, what we did was first buy some scrap metals and compare this quality to the commercial electrodes. We took some samples and compared their purity using the spark emission spectroscopy, giving great level of purity. For the ion, the 99.5, and the aluminum 96.8, which was really good. But besides this, we did some validation tests in the lab using the maximum current density just to check that the dissolved impurities were within the limits of discharge. Okay, so everything was safe for the biological treatment and the discharge parameters. As these results were good, we considered that the electrodes were suitable to produce the coagulants. We bought all of them, and after that, we proceeded with the installation of the electrodes in our electrolytic system. We bought them, then we had to take a lot of times the measurements of the electrodes. As you see here in the presentation, we used a wooden electrode, and to check that they fit inside the reactor. Regarding the connections, nothing is left to chance. The section of the connections have to be carefully calculated considering the different conductivities of the iron, the aluminum, and the copper wire to make sure they could resist the current that was going to flow through them, and so make everything safe. Then, I don't know if in the picture it can be seen that all the anodes are connected to one side of the plant, to this bus bar, and all the cathodes are connected to the other side of the plant, just for the sake of safety, so the operators can be safe as well. Finally, we are showing you some pictures of the coagulants. In the left one is the iron coagulant, and in the right picture is the aluminum coagulant that we have produced in the plant. And of course, we have here the VIP visitor that came once to the plant, the dragonfly. And as the conclusions, we have overviewed the process. We have seen the advantages of the LIFE Waste2Coag solution. Then the scrap metals, we could valorize the scrap metals into coagulants in a pilot scale and generate them with good results. And finally, we would like to emphasize that there is no magic in here. Everything has been calculated, and the design of the plant has been based on the coagulants that we aim to produce. This was based also on the operational parameters, and depending on the validation results that we checked the efficiency of the coagulants. Then we had to optimize the production again. So everything is an iteration, which means that there is a lot of work that has been done, but there is still a lot of work that needs to be done. So thank you for listening. I hope the content was interesting and useful. I don't know if you have any questions. Okay.